Welcome to LNB Renewable System Integrators. Today we are going to see some of the basics of a chiller system from the BMS and the BACS engineer's point of view. So while entering into the topic, let's try to ask some of the questions to ourselves. One is, what is a chiller, how they looks like, and why should I know about these chillers, where can I use this, and what are the things as a BMS engineer I should know in chiller. So a chiller is a centralized system that cools the air for the building. Okay, mostly it is used in all the HVAC systems. Okay, in the HVAC system, if you consider AHUs, VABs, FCUs require cooling water, okay, to absorb the heat from the building and take it outside. So for that purpose we need a cold water. So for the preparation of cold water we need a chiller plant. Okay, so chiller plants are of different types. One is a main centralized chiller plant. From that chiller plant we can take with the help of the different primary and secondary heat exchange system and pumps, we can take into the building and we can supply. Okay, and most probably it plays important role in energy saving process. And in certain cases for the chillers, water is used as a coolant, or in certain cases refrigerants are used, but most probably water is preferred. Okay, how they looks like, this is how they looks like. There are different, so many models are there. So this is how the chillers looks like. So why should I know about this chillers? Very simple. If you're going to work in any malls, metro stations, multi-storage corporate offices, storage yards, ports, okay, in all these locations, building automation system will be there. Okay, for the building automation system, in the as a part of a building automation, HVAC systems will be there. So this HVAC system plays important role in maintaining the air circulation inside the buildings. So for that, so many equipments are there in the HVAC systems, air handling units, variable air volume units. All these units require chill water. For that we need chillers. Okay, so this is one of sample graphics how the chillers looks like, and these are the pumps. So there is a separate pump for supplying and a separate path for the taking the return water from the building. So where can I use this? So it is used in, as we told earlier, it is used in metro stations, multi-storage buildings. Okay, and it plays important role in supplying the chill water to the air handling units and fan coil units. This is one of the sample typical diagram of a chiller. See here, it is taking the it is supplying the chill water to the building. Okay, and it is taking the water from the main chillers. Okay, it is already pre-cooled. Okay, and also see here, these are the heat exchangers. This is the primary side of the heat exchanger, and this is the secondary side of the heat exchanger. See here, valves are present here. Okay, and also temperature sensors and are also present here. PDAT is also present here. Okay, and in the secondary side also temperature sensors are present, and also control valves are also present. Apart from it, we have 4 pumps. In this one, 3 act as a main, and the fourth one will act as a duty. Okay, apart from it, in the return line also, in order to know the temperature and the flow, we are using the flow transmitters and temperature transmitters. And to calculate the potential difference, differential pressure between the supply and the return line, we are using the pressure transmitters. Okay, this is a sample example of a chill water system. Okay, based on the requirement, the number of heat exchangers will differ. Okay, see here these 4 heat exchangers are playing important role in transferring the heat from the building chill water and supplying chill water to the building. Okay, and see, this is plays important role in a portable water tank. Okay, so if you look into the chillers as a PLC programmer or a BACS engineer, we need to follow the following signals. So if we get into the hardware signals, remote status, run status, fault signal, start, stop, speed control, and speed feedback, differential pressure switch, all these things we need to monitor. And also we can communicate through the Modbus RS485, and we can get the soft signals from the VFDs. Okay, And also in the heat exchange side also, as we told earlier, we have a differential pressure transmitters, temperature transmitters, temperature controlling valves, okay, and for isolation purpose also we have a separate valve. So all these valves we can able to command, okay, we can able to communicate with the help of profile-based communication, okay, through the PLCs. And even on the second heat exchanger also like this, same thing follows for the third and the fourth. So as we told earlier, we are using so many sensors and pressure switches. So those are all digital signals we can monitor. Even the flow transmitters, supply temperature sensors, pressure transmitters, everything through the Profibus we can monitor all the parameters. This is one of the schematics how it is being connected with the digital input, digital output, analog output, and communication signals with the PLCs. Okay, and before knowing knowing about the chillers, we need to know the process which is happening in the HVAC system. See here, the air is coming. Okay, the cooling coiling plays important role in cooling that particular air which is getting supplied to the building. Okay, and it is taking the heat and it is going to the evaporator through the help of the chiller pump. It's going to the evaporator. Okay, in the evaporator there is a refrigerant, okay, which helps to cool the water, and from there it's going to the compressor. In compressor water is there, so it acts as a condenser, okay, and with the help of the condenser pump it is getting pumped to the cooling tower. So by the cooling tower with the help of air, okay, it is making the water cool and it is again recirculated inside the building. This is how a heat transfer loop happens in the HVAC system. So if you want to know in detail about the chill water system, so primarily we can take the prepared chill water from the centralized plants, that is 5.5 degree from the district chill water system. Okay, there are, as we saw earlier, there are 5 heat exchangers. 4 plays important role in supplying the chill water to the building for the purpose of various systems, AHUs and the FCUs, and one heat exchanger is used to cool the portable water tank. Okay, so as we told earlier, we have 4 pumps there. They are being controlled by the variable frequency drives. In that one, 3 act as a duty, and the fourth one will act as a standby. So we can make a schedule and we can shift the duty to standby and standby to duty as well. Okay, and also we have 2 port motorized control valves. Okay, and in the secondary pumps, which is being connected to the VFDs. Okay, and most importantly, what as a role we are going to do. Now, that is a BACS engineer or BMS engineer. We are going to control the speed of the pump between the minimum and the maximum limit during the normal pressure control. Okay. So thank you so much. We had seen the part 1 of this chillers. In the forthcoming videos, we will try to know about the sequence of operation which is happening in the chiller system. So in the now we can saw what is chill water system, how it looks like, where we are using it as a VMS point of view, what are the IOs we need to know about, and what are the equipment which are being present in the chiller system. Now in the forthcoming sessions, let us try to know the sequence of operation of these chillers. If you have any inquiries, feel free to contact us. We are ready to serve you. We are doing the projects in the industrial automation system. We are providing the design, installation, testing, and commissioning support for solar power projects as well. Feel free to contact us. Thank you.